Alright folks, we're going to do a couple of gas law problems. We're going to start off with some examples from the notes. First one's going to be number 9 about Lussacs law. And what you do, first thing you got to read the question. So before a trip from New York to Boston, the pressure in an automobile's tire is 1.8 atmospheres at 20 degrees Celsius. At the end of the trip, the pressure gauge reads 1.9 atmospheres. What is the new Celsius temperature of the air inside the tire? Assume constant volume and number of molecules. So what that means here, our constant volume and number of molecules, is that because they're not changing, they would be the same on both sides of an equation, so we can just ignore them for this one. So even though we mentioned volume, this problem is not going to involve volume, and even though we mentioned molecules, we're not going to involve that either. So after you read it once, read it again, trying to pick out the pieces of information that are going to be pertinent for us. So we got a pressure of 1.8 atmospheres at 20 degrees Celsius. So at the same pressure, our temperature is 20 degrees Celsius. At the end of the trip, our pressure gauge reads 1.9 atmospheres. I forgot the T there. Okay. So what is our new Celsius temperature in this? So we got initial temperatures and pressures and final temperatures and pressures. And we're looking for T2. So the formula we're going to use is going to be the one that relates pressures and temperature, and that's P1 over T1 is equal to P2 over T2. And I know that because I've got my shopping list here. Just go take your shopping list to your list of formulas and find out which formula includes just what you're looking for. The thing that we have to do before we plug our numbers in, though, is anytime you're doing these gas laws, our temperature must be in Kelvin. So to do that, we're going to add 273 to this. This brings us up to 293 Kelvin. Now I know the problem asks us for a new Celsius temperature, so when we're done with our calculations, we're going to have to subtract about 293 from it. So now what I like to do, you can plug your numbers in as it is right now, but I prefer to rearrange the equation before our numbers go in to get what we're looking for, in this case T2, all by itself. Now, whenever you're trying to solve stuff for the denominator of a fraction, I find the best way to do it is to get rid of the fraction altogether. And that's by cross-multiplying. So I'm just going to cross-multiply this. I get P1 times T2 is equal to P2 times T1. Still hasn't gotten T2 out of the way, but it's going to help us prevent some errors in the future. So now to get T2 by itself, we're going to undo the multiplying by P1. So I'm going to divide by P1. Over here, P1 is going to cancel. And now I'm just left with T2 is equal to P2 T1 over P1. And I'm ready to plug my numbers in. So my P2 is 1.9 atmospheres, and my T1 was 293 Kelvin, and my P1 was 1.8 atmospheres. And we're going to cancel out my atmospheres, and that's just going to leave me a temperature in Kelvin. So you go over to the old calculator, 1.9 times 293, hit enter. We're going to divide that by 1.8. And we get an answer for this is going to be 309 Kelvin. So if you left it like this, you'd get a point taken off because we want it in Celsius. So now we're going to subtract 273 from it. And if I do this, this is going to be a Celsius temperature of, not 39, 36.3 degrees Celsius. So that's a Lussacs problem.